Convection currents are the circular movement of hot and cold material in the Earth's upper mantle. The hotter material rises, but as it moves closer to the crust, it begins to cool down and sink. It will then heat up and rise again. Diverging or constructive plates are tectonic plates that move away from each other to make way for a new plate to emerge. When this occurs underwater, the magma cools on the sea floor and forms a new layer of solid crust, which is added to the plates as they move apart. A popular example of diverging plate boundaries is the Mid-Atlantic Ridge, where the plates have moved away from one another, causing a ridge in the ocean floor. This has caused gaps on the surface for the magma to push through and cause a volcano. Diverging plates on land create a rift valley and cause hazards such as volcanoes and earthquakes. An example of a rift caused by a diverging plate is the East African Rift, which is 6,400 kilometres long and averages a width of 48 to 64 kilometres wide and travels through Ethiopia. Also referred to as destructive, converging plate boundaries occur when an oceanic plate and a continental plate collide. The denser oceanic plate will subduct beneath the less dense continental plate. The oceanic plate will melt in the mantle from the extreme heat of the magma. This process creates gases and enormous pressure. These gases often escape to the surface along the lines of weakness, causing a zone of volcanoes and continuous volcanic activity. Converging plate boundaries also result in shallow earthquake activity along the continental margin. An example of the effects of converging plate boundaries is the Andes Mountains, which have formed from the Nazca oceanic plate subducting beneath the South American continental plate. The Andes mountain range passes through Colombia, Ecuador, Peru, Bolivia, Argentina, and Chile. Transform plate boundaries occur when two plates move horizontally with one another along a fracture zone where the Earth's crust has a distinct fault or breaks. Transform plate boundaries usually move in different directions, but sometimes they move in the same direction at different speeds. Transform fault plate boundaries are described as conservative boundaries because plate material is not created or destroyed in the process. These zones often experience frequent and violent earthquakes, caused by the build-up and release of strain as the plates move past each other. However, volcanic activity is not common. A well-known example is the San Andreas fault line in California, which caused many destructive earthquakes.
A shield volcano is a broad, domed volcano with gently sloping sides. It is named for its low profile, resembling a warrior's shield lying on the ground. Shield volcanoes are formed by running lava that flows easily down the volcano. Consequently, a volcanic mountain having a broad shape is built over time by flow after flow of relatively fluid basaltic lava issuing from vents on the surface of the volcano. Kilauea is an active shield volcano in the Hawaiian Islands and the most active of the 5 volcanoes that together form the island of Hawaii. Located along the southern shore of the island, the volcano is between 210,000 and 280,000 years old and emerged above sea level about 100,000 years ago. Its first recorded eruption was in 1823 and is constantly active and erupting. A composite volcano is formed over hundreds of thousands of years through multiple eruptions. The eruptions build up the composite volcano layer upon layer until it towers thousands of metres tall. Some layers might be formed from lava, while others are ash, rock, and pyroclastic flows. Unlike shield volcanoes, composite volcanoes are characterised by a steep profile with a summit crater and periodic intervals of explosive eruptions and effusive eruptions. The lava flowing from the composite volcanoes typically cools and hardens before spreading far due to high viscosity. Mount St. Helens is a composite volcano located within the Cascade Mountains. On March 20, 1980, a cluster of small seismic events near the volcano were recorded. A week later, steam and ash began ejecting from the dome. The following week, geologists arrived to monitor a large bulge forming on the mountain's north side. By the end of April, the bulge was expanding at a rate of 1.5 metres per day, and scientists began to monitor gas emissions for sudden increases, often an indicator of an eruption. Between May 15th and May 17th, the following day, at approximately 8:32 in the morning, a magnitude 5 earthquake caused a debris flow on the north slope. The loss of overlaying rock released gas and magma from the volcano, resulting in a lateral blast of rock, ash and gas.